Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm extremely glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 2002, maximum product of the length of two palindromic subsequences. So basically you're given a string of S and you want to find two subsequences, basically two non-subarrays that are parts of S where they don't share the same index and they're both palindromes, and then meaning the same forward as backwards, and then you want to multiply their lengths and find the biggest length and return it. So let's do exactly that. Okay, so let's define an answer. And then let's go ahead and generate all the subsequences. So let's do that using the size, or we can just call this current, because what we're going to do is first generate all the indexes from 0 to length of S up to not including, because at this point we know that we're going to make sure that the indexes are not shared between either of the subsequences. So for J and combinations of current and of size I, so this is going to give us all the combinations, and then now we can basically just declare an array to get the actual characters, right? Because these are just the indexes of S, so from 0 to 1 to 2 to 3 to 4 to however long S is, minus 1. And then let's go ahead and go through J, because we know those are the indexes, and then we're going to append the actual character. And then if now is equal to the reversed, we know it's a palindrome, so then let's print now and J. Cool. So then we can go ahead and add that to a list called total, and we're going to just append a copy of now and then J, because now we can basically just loop through this using a double loop. And the double loop is just going to check every single pair. And basically, so let's call this 1 and 2 is total of I and total of J. Let's print 1 and 2. So basically, if these have any overlap, then we know it's not valid, right? So let's call this 3 is set 1 dot intersection set 2, because that's just going to give us, for example, if we have 1 and 3 and then we have 1 4 3, then this is going to be the union, which is just 1 3. So if length of 3 is less than or equal to 0, then it's going to be valid, because we already know that this is already a palindrome, which is even why we put it into the list. Okay, so intersection set 2. Okay, total I of 1, because the first index is the actual index subset or combination, right? Which we don't want to overlap. Okay, so basically now we can actually go ahead and say, okay, these are valid, right? There's no indexes that are shared between them, and then we can just take the length of 1 times the length of 2, right? It says here the product of their lengths, so times length of 2. So if you have, this would be 1 times 3, this would be 2 times 2, etc. And then at the end we can just return answer, right? Okay, let's run this. Okay, submit it. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.